Hello, everybody. In Chapter 9, we're going to be talking about production and operations management. So we're going to be talking about factory settings, everything that kind of goes along with running a factory and manufacturing. So to kind of go through the contents here, we got manufacturing and services in perspective, from production to operations management, production processes, operations management planning, control procedures with PERT and Gantt charts, and then preparing for the future. So I wanted to use this example. Mr. Khan here, he is currently the owner of the Jacksonville Jaguars. He's also a University of Illinois graduate. So he moved from Pakistan to the United States at the age of 16. After college, he got a job overseeing Flexengate, and then he bought the company after 2 years and refined the production process. So Flexengate, I mean, they were doing a lot with like bumpers and creating bumpers for auto manufacturers. So after he bought the company, refined the production process, and now the company is worth about $7 billion. So he's a very wealthy individual, but I thought that was pretty cool individual to use as an example, just because I mean he did go to the University of Illinois over here in Champaign, and now he owns the Jacksonville Jaguars. So manufacturing in the U.S., when you think about manufacturing here in this country, we kind of started with manufacturing, with like Ford and all the factories that were up and coming in the early 1900s all the way through the 1920s and so on and so forth. So since 1979, the number of U.S. workers employed by factories has steadily dropped. American factories can operate efficiently without large amounts of human labor, just because we're getting more effective, and a lot of that is thanks to operations management. What's made in the U.S. So here are some of the examples of things that are still manufactured here in the United States. So a lot of chemicals, pharmaceuticals, cosmetics, soaps, paints, fertilizers, a lot of transportation equipment such as cars, planes, trains. Processed foods, beverages, tobacco, cookies, coffee, and then computers, and electronics, kind of rounding out the top four here. So these are the top 10 U.S. manufacturers. We've got ExxonMobil, Apple being a big one, General Motors, Ford Motor Company, and not a big surprise that we have some motor vehicle manufacturers there at the top. But even down we've got IBM under computer electronics, along with Apple, Boeing under aerospace and defense. So pretty wide variety of things, but most of these companies we could probably think of if we were in class and talking in person about it. So the U.S. economy is no longer manufacturing based. 80% of the jobs are in the service sector. American factories can't fill positions as engineers and computer experts flock to the tech industry. So, unlike their predecessors, modern factory robots can safely work side by side with humans. Do you think that manufacturing could someday be driven entirely by automated labor? Um, I don't think it can, just because you're going to have that human element to it, just for quality control, just to make sure, first off, that the robots are running the way they should be, and if a robot does kind of go off of queue and isn't functioning properly, then another robot isn't going to be able to recognize that. So I mean, there's definitely a need for a human to kind of be there observing everything. And plus, I mean, we need humans to work on those robots as well. So manufacturers and service organizations become more competitive. U.S. manufacturers compete with China, Germany, South Korea, India, so on and so forth, everywhere around the world. How can U.S. businesses maintain a competitive advantage? Well, keeping up with the latest production techniques, focusing on customers, maintaining close relationship with suppliers, and then practicing continuous improvement. We're going to go over some of these, techniques that we use for, protection, such as, just-in-time manufacturing, Six Sigma, different things like that, that have been, a huge advantage for us here in the United States, even though they are, universal, everywhere around the world. But we're kind of mastering here in the United States, here within the last few years, to hopefully give us a little more competitive advantage. So production, that's just the creation of finished goods and services using the factors of production such as land, labor, capital, entrepreneurship, and knowledge. And then production management, just the term used to describe all the activities managers do to help these firms create the goods. We've got operations management, which is just a specialized area in management that converts on or transforms resources, including human resources, into goods and services. Operations management includes inventories management, quality control, production scheduling, follow-up services. Um, if you do go ahead and go through with a bachelor's in business, you're going to also take an operations management course. It's a very interesting course where you do learn a lot more about the things we're going to talk about in this chapter and kind of dive into it a little bit deeper. It was probably one of my favorite classes going through college. Learned a lot about it, and it kind of helped me just become a more efficient and a more effective manager later on once I did get a job. But I've got a couple of buddies who are working in operations management currently. I love talking to them about kind of their processes and kind of what they do in their own job. One of my friends works for Growmark, out of Bloomington, and they do a lot with ag resources and just making sure that you know corn and soybeans and other commodities are getting to where they should. And with his job, he's pretty much kind of in charge of making sure that um, with transportation, that's kind of lined up for all of the resources that we're providing all over the world. So he's in constant communication with airlines, with railroads, different services like that. And he was kind of showing me one day, kind of how corn will go from Bloomington, Illinois, and then it'll be on a semi truck. It'll go over to the Illinois River in Peoria, be dropped off into a barge. It'll go onto a barge for a couple of weeks, go down the Mississippi River, go down to New Orleans. In New Orleans, it'll go from a barge, get onto a huge ship, and then it'll go pretty much anywhere in the world, whether it's Africa, Asia, wherever it might go. So that was just kind of cool to think about, kind of how one kernel of corn here in Central Illinois can go such a far distance just based on of the resources that we have here locally. So operations management is in the service sector. It's all about creating a good experience for those who use the service. In hotels like Hilton, operations management includes smooth running elevators, fine restaurants, comfortable beds, and a front desk that processes people quickly. So it's all part of that. And I mean, we've started to see more of operations management be implemented pretty much in everyday life. Whether you're going to Walmart and you're getting checked out, I mean, that's part of the operations management at Walmart. You're going through McDonald's, going through the drive up. They put a lot of emphasis on operations management. So it's one of those things that's very relatable, and it's a lot of different places that you probably didn't think about until now. So a couple of things here. There's a lot of productivity apps for your iPad or your smartphone. So the one that I wanted to point out here is we do have Mint, which is a budget control app. You can go out there and kind of see how you're spending your money. Is there ways to cut back? I had used Mint for a little bit. It was actually a pretty cool app. I enjoyed using. I ended up using now SIFQ kind of has our own app that we kind of started, so I use that now. But for the most part, I enjoyed my time with Mint. I thought it was a pretty cool thing to help me save money in the long run. So for production processes, here's just kind of a quick figure to kind of show. Starts out with your inputs such as your land, labor, capital, entrepreneurship, knowledge. Goes on to production controls such as planning, routing, scheduling, dispatching, follow-up, and then you got your outputs of goods, services, and ideas. So with the production process, you're going to form utility, which is the value producers add to materials in the creation of finished goods and services. So GROW's basic production requirements is to build and deliver products in response to the demands of the customer at scheduled delivery time, and to provide an acceptable quality level, and then also provide everything at the lowest possible cost. So process manufacturing, that's going to be the part of the production that processes that physically or chemically changes materials. And then we got the assembly process, the part of the production process that puts together components. Production processes are either continuous or intermittent. So continuous processes, long production runs, turn out finished goods over time, and then intermittent is the production run is short and the machines are changed frequently to make different products. So for continuous products or for process, think about something like, at a Coca-Cola factory. I mean, they're doing long runs of production of Coca-Cola, around the clock. With intermittent process, I actually got a factory, or went to the Ben and Jerry's factory in Vermont. Was about 2 years ago. I was up there, and although they are producing ice cream, they are doing intermittent processes of different types of ice cream. So that does require them to have a little bit different machines for each of the different types of ice cream and a little bit different processes just because of the ingredients that go into it. So that would kind of be an example of the kind of the intermittent ones. So production of some of the Americans' favorite products. So here we've got, Krispy Kreme donuts, number of items made in minutes. So they're making about 5,200 donuts per minute. Chips Ahoy cookies, about 4,000. Twinkies, Jello boxes, Lifesavers. So, a lot of food-based items there. Um, we have a Krispy Kreme here in Springfield. Got one up in Bloomington. My dad actually installed some of the machines up in the one in Bloomington, so I kind of got to go and watch the machines go in from the start, and then got to see kind of the first kind of test run of donuts going through there. So that was a pretty cool thing for me, being I think it was about 11 or 12 at the time, kind of seeing everything that went into creating a Krispy Kreme donut shop, and then the final product of it. So the need to improve production techniques and cut costs. So over the years, developments making U.S. companies more competitive had included computer-aided design and manufacturing, being flexible in the manufacturing, lean manufacturing, mass customization, robotics, and 3D printing. And we'll go through all of those in the next few slides. So computer-aided design, that's just the use of computers in design of products. Computer-aided manufacturing, the use of computers in the manufacturing of products. So pretty much just letting the computer kind of think its way through everything, and helping out to create something a little more effectively and a little more efficiently. In computer integrated manufacturing, the uniting of computer aided design with computer aided manufacturing. CIM is expensive, but it drastically reduces the time needed to program machines to make parts. Flexible manufacturing, designing machines to do multiple tasks so they can produce a variety of products. Alan Bradley uses flexible manufacturing to build motor starters. Machines and robots build tests and package parts. So I know, like, a lot of assembly lines for, like Ford or GM or something like that, their assembly lines, they will set them up in a certain way to where they can use the same machine to build different types of automobiles, whether it is a truck or whether it's a small car, different things like that. That way they're kind of getting more bang for their buck and not having to build multiple factories for some of those cars. Now they do have multiple factories to kind of build different ones, but the way they've got them set up, it's a lot more I guess strategic and flexible than it used to be when they first started out with the production line. Lean manufacturing, this is one of those topics you'll hear a lot about throughout operations management, and that's just the production of goods using less of everything compared to mass production. So compared to others, lean companies take less human effort, take less manufacturing space, require less investment in tools, and they require less engineering time to develop a new product. Essentially, you're just kind of pushing out products based on the demand of the products. You're not just constantly pushing out products just because. You're cutting down on waste with those products, and there's not as much effort going into it. So I had a professor in college who told me one time he used to work for General Motors. General Motors used to have a lot of just supply on demand as far as steel going into the automobiles and just tires all over the place. and then one day they started um, implement lean manufacturing, and they kind of figured out they didn't need all of this extra stuff kind of lying around. They were just kind of wait to see what their production needs were at the time, and then at that point they were going to order it and then start to build cars from there. So it took less human effort on their part, took less time manufacturing, it took up a lot less space just because they didn't have to have the warehouses for all the extra materials. Mass customization, something that you've probably started to see and maybe not known about it. So, tailoring products to meet the needs of individual customers. One of the first organizations that was doing mass customization was Dell Computers. You could go onto Dell's website, you could order a computer, you could order however much storage that you wanted on it. You could order a different color, different size screens, that sort of thing. But it all fits into a mold, and now pretty much every computer. Out there is based on mass customization. So I mean, it's the same way like Apple. If you go onto their website now, you can, whether you're ordering an iPhone, whether you're ordering a MacBook, you can go out there, you can pick your color, you can pick kind of the size screen you want, you can pick kind of whatever you want with it. But at the same time, it's kind of limited on the amount of choices that you have, but it is customized to you. So more manufacturers are learning to customize, and then mass customization exists in the service sector too. So in the service sector, if you do have, say, like if you're in the cleaning services, you might offer different programs and different kind of cleaning services for different jobs, and it's just kind of like a package deal. Robotics, the use of robotics allows manufacturing to continue 24 hours a day, 7 days a week, with great precision. Robotics have improved productivity while reducing the number of jobs for humans, and then robots work in service businesses such as hotels as well. 3D printing, this is a relatively kind of new thing. So products are created one layer at a time by a nozzle, and for now 3D printing is typically used to make prototypes and molds. The reason why we didn't have a whole lot of 3D printing up until about 5 years ago is there was a patent on 3D printers. The patent came up in about 5 years ago, I think it was, and now there's just been this new wave of 3D printers coming out. So we're going to start to see a lot more with 3D printing. I think that's going to improve a lot of processes in the future. Using sensing, measurement, and process controls. So sensors can detect the moment anything goes wrong, and then nano manufacturing allows manipulation of materials on a molecular and atomic scale. So for operations management planning, it helps solve problems like facility location, facility layout, material requirement planning, purchasing, inventory control, and quality control as well. So for facility location, the process of selecting a geographic location for a company's operations, rising number of online businesses mean brick and mortar retailers must find great locations. I mean, I'll just kind of use an example. Here, I live in Lincoln, Illinois, so Lincoln, Illinois is right next to an interstate, 55. We had a Cisco plant put in not that long ago, and they use it as a hub for a lot of their trucking. Same way FedEx has the same thing here as well. We're kind of based right next to an interstate. It's a lot of, it's very easy for them to get out on the interstate and again, kind of truck their products anywhere that they need to go, and for their deliveries. So, whenever you're looking at geographic locations, kind of look at, are there rivers near you, or is there an airport near you? Is there, interstate near you? Because that's a lot of the times what these companies are looking for whenever they're starting up with a new business or a new factory. So considering for moving facilities to a new location, this also includes labor costs, availability of resources, access to transportation, proximity to suppliers and customers, crime rates, quality of life for employees, cost of living, need to train or retrain local workforce. So here recently, Amazon, they were coming out with their, second headquarters. There was a bunch of people or a bunch of cities that were in the running for it. I think Chicago was in it for a little while, Austin, Texas, Boston, and they ended up settling with New York. And then it got to the point where New York, they didn't want to really have them because they didn't want to make any concessions when it came to tax deductions. So New York pretty much told them no. And now Amazon is kind of going elsewhere. They're going kind of in the Washington D.C. metro area, but they're also kind of going also in like Nashville. They're putting a bunch of jobs down there and everything. So whenever some of these manufacturers or companies are looking at different areas, it's a lot to take in. And I know, like for Amazon, that was a couple-year process that they took to decide on New York, and then New York ended up not wanting them. Interfirm operations management. So sometimes businesses outsourcing, engineering, design, and manufacturing to other companies. Often these relationships are managed through the internet, and then many companies are developing internet-focused strategies. So facility location in the future, information technology gives firms increased flexibility in terms of location. Telecommuting, working from home via computer and modem. Excuse me. I know telecommuting, that's becoming a bigger part of my job, just because I mentioned in a previous chapter that we do have member centers out in California. So we do have quite a few meetings with some of the staff out there. In California, we do it through telepresence, and we're not like a big multinational corporation at all, but other places like a State Farm, where they do have large presences here in Central Illinois. They have offices in Atlanta, Georgia, Dallas, Texas, Phoenix, Arizona. They do a lot with telecommuting as well. Facility layout, the physical arrangement of resources, including people, in the production process. So facility layout depends on the process performed, such as service, help customer find products, manufacturing, improve efficiency. So with facility layout options, there's assembly line layout, where workers do only a few tasks at a time. You have the modular layout, which teams of workers produce more complex units of the final product. Fixed position layout allows workers to congregate around the product. And then process layout, which is similar equipment and functions are grouped together. So here's an example of the product layout where, kind of going in one at a time down the line. This is just kind of like the typical assembly line layout that you think about whenever you think about an automobile. For process layout, you're starting out here with, storage down to cutting, and then you're going down to two processes at one time with, stamping and assembly. You're going from stamping to deburring down to bending, but also from deburring, you're also going to assembly. So you got a lot of things going into assembly at different times, and then from assembly down to packing and shipping, just because there is such a high priority on assembling. Cellular and modular layout, you're going from 1 to 2, and then from 2 to 2, and then kind of doing a crisscross, and then down to 1, down to assembling a table finally. So a lot of moving parts in that one. And then fixed position layout, think about a house. You've got roofing contractor, general carpentry and supplies, grading equipment, architect, painting contractor, finished carpentry, plaster contracting, plumbing contracting. I mean, there's a lot of things that are going into this. Usually the general contractor will, get everything kind of in line from the start, figure out timelines of everything. We got a couple of techniques on figuring out those timelines that we'll go through here in the next couple of slides as well. So material requirement planning, materials requirement is a computer-based operations management system that uses sales forecast to make sure that needed parts and materials are available at the right time in the right place. So Walmart uses this. What they do is, based on their inventory system, if, they need paper towels at one of the stores in Springfield and there is a truck that is on the way to St. Louis, the truck will get an alert saying that, hey, we need paper towels in Springfield. The truck will turn around if they have paper towels on the truck and go back to that Walmart and make that delivery for them. So, they're constantly, en route, making sure that everybody has exactly what they need, and then that way there's no shortages, and that way, they have happy customers at all times. So, enterprise resource planning, a new version of MRP that combines computerized functions of all the divisions and subsidiaries of the firm, such as finance, human resources, and order fulfillment, into a single integrated software program that uses a single database. So, I think Walmart is, slowly working towards that, as well as many organizations currently are. Purchasing, you've got the function in a firm that searches for quality material resources, finds the best suppliers, and negotiates the best price for goods and services. The internet has transformed purchasing. It used to be a thing where you would have a salesman that would be, going from manufacturer to a manufacturer, trying to go through the sales pitch. With so much information out there on the internet right now, there's really not much of a need for that anymore, where a lot of people can just kind of stay where they're at. They don't have to check in on possible buyers anymore, and they can just kind of do all their sales through the internet. So just-in-time inventory was kind of what I was talking a little bit ago about with the GM manufacturing and lean manufacturing. It's a production process in which minimum of amount of inventory is kept on the premises, and parts and supplies and other needs are delivered just in time to go on the assembly line. To work effectively, the process requires excellent coordination with suppliers. So you need to be in constant contact with your suppliers to kind of figure out when can I get tires here, when can I get steel here, that sort of thing. I mean, if there's going to be a delay in that, you need to order that pretty early on. But the good thing about the just-in-time inventory control is you're not needing extra warehouse space um, to store all of your inventory, just because you don't have the need for it. So it takes some getting used to with just-in-time, but I know a lot of organizations have really seen some good things out of it, especially auto manufacturers. So quality control is a very big thing. We've got consistently producing what the customers want while reducing errors before and after delivery to the customers. I used to have a professor in college who, whenever we were talking about quality control, think about a can of Coke that goes through the assembly line. So the can starts out, it gets filled up, and then it gets sealed, and then it's delivered. But then you've also got this thing called standard deviation. So with standard deviation, in each can of Coke, you want 12 ounces of Coke in there. But it's not going to be 12 ounces every time. Sometimes it's going to be maybe 11.4 ounces, and sometimes might be maybe 12.4 ounces. So you're kind of going to go a little bit less than 12, a little bit more than 12, but the standard deviation of that should be 12 at all times. But every once in a while, you will have things that will go outside of the bell curve in those situations, and you will get cans of Coke that'll only be 6 ounces in quantity. So my professor at the time, what he liked to do is he liked to collect different cans of soda that were only halfway full, and they were sealed and then sent out for delivery. So it was kind of a cool thing. He would bring them to class, and he had all sorts of like different Coke ones. He had different like Sprite, root beer, whatever it was, just different types of sodas that were, some of them were only half of the way full, some of them were 3/4 of the way full. But yeah, it was just kind of cool to see how quality is affected in just something simple like a can of Coke, where you wouldn't really necessarily expect that to happen. And then going down here to Six Sigma quality, a quality measure that allows 3.4 defects per million opportunities. So Six Sigma is getting to be a very popular thing. You can become like a black belt in Six Sigma, and we'll kind of go over it here a little more detail in a couple of minutes, but it's crazy how much emphasis has been put on the Six Sigma, and trying to reduce defects per million, and it's really a big thing in manufacturing. So as far as the process, you've got to define your processes. What are you trying to accomplish? You've got to measure them, how well you're doing it, analyze everything, improving on the processes, and then just the overall control. So as you can see here, you've got all 6 steps in producing a quality product. For quality control continued here, we've got statistical quality control, which is the process some managers use to continually monitor all phases of the production process to assure the quality is being built into production from the beginning. And then statistical process control, which is the process of taking statistical samples of product components at each stage of the production process and plotting the results on a graph. So measuring quality along the production process reduces the need for quality control at the very end. So ISO 9001 and ISO 14001 standards. These are international organization for standards. It's a worldwide federation of national standard bodies. So the 9001 is the common name given to quality management and assurance standards, and then the 14001 is the collection of the best practices for managing organizations' impact on the environment. So program evaluation and review technique, or PERT, is a method for analyzing the tasks involved in completing a given project, estimating the time needed for to complete the task, and identifying the minimum need to complete the total project. So the steps involved with that is analyzing and sequencing tasks, estimated the time needed to complete each task, and then drawing a PERT network illustrating the first two steps. Identifying the critical path, which is the sequence of tasks that take the longest time to complete. So have you see here a PERT chart for a music video. So you're starting out with a song. You've got start and song is chosen, and then it kind of splits. So you've got the set design, set materials purchased, set constructed, dance is rehearsed. Then you go down below. You've got costumes designed, dancers measured, costumes made. And then you've got dancers selected, and then dance choreographed. So as you can see, the critical path is the one on top, just because that's what's going to take the longest. Is just going from a start of song is chosen, set design that took 4 weeks from a set to the set materials purchased. That's another 2 weeks, and then ultimately 6 weeks from the purchased materials to the set being constructed, and then finally, the dance rehearsed. Everything is rehearsed. That took 1 week, and then finally the video was filmed. So through it all from the start, we've got 1 week plus 4 weeks that were 5, 7, 13 weeks. 14 weeks and 15 weeks there. So almost pushing 4 months just for a music video. So kind of crazy whenever you kind of plot everything out, how much time that took just for one music video. A lot of times you probably see a music video, some of the music videos that are out there, pretty basic, or so he might think and think, oh, it only took maybe a couple of days to do that, but in reality, probably took 4 months. So a Gantt chart is another chart that you can use when deciding how much time it's going to take for production managers. So just a bar graph showing production managers what projects are being worked on and at what stage they are at any given time. So here's an example of that one. So the white illustrates the completed work, and then the orange is work that needs to be done. So in this one, you've got machine A, they're molding the heads. Machine B, bodies mold. We've got fabric cut. We've got clothing being sewn. Finally, the assembly and the painting for a complete doll. So yeah, you can kind of go down and see total time be 7 weeks. And you can kind of check in at each point and see kind of where everything is at based on what color that you have. So as far as preparing for the future, there's a lot of opportunities exist in careers in operations management. Those who see futures trends and have skills to work in the highly automated factories will benefit. I would say overall, if you have a lot of interest in math, if you have interest in manufacturing, in just improving overall quality, being very efficient, being very effective, operations management is probably a pretty good field for you to get in. And it's something that I've always enjoyed kind of doing. I don't do a whole lot of it anymore, but if it's something that you really like, I definitely recommend it. So that's all I got for this chapter, and we will see you in chapter 10.